This video is about equilibrium. Equilibrium means that the sum of the forces is equal to zero. So this first bullet is a vector statement of that, but we'll pretty much almost always talk about net force, which is what this says. It says the net force is zero in terms of the net force in the x direction and the net force in the y direction. So if the net force is zero, that means the net force in the x direction is 0 newtons. The net force in the y direction is 0 newtons. And by Newton number 2, which says that the x component of the acceleration is the net force in the x direction divided by mass, this fact, the net force in the x direction being 0, means that the acceleration of the object under study is 0 meters per second, and similarly the y acceleration of the object is 0 meters per second. And so these both mean, respectively, that the v sub x is constant, the x component of the velocity is constant, and the y component of the velocity is constant. So equilibrium, just generally speaking, has two different branches, two different types. One is static, where the velocity is zero. And if the vector velocity is zero, well, that means that both the x and the y components are zero. And this is the situation we had in the force table, where the velocity of the ring in the force table, that was the object under study there, when you think about it, was zero. But the other situation you can have is dynamic equilibrium, which means that the magnitude of the vector velocity is bigger than 0 meters per second, but it's constant. And so an example of that would be, for example, terminal velocity. If I took one of those cones that I showed, that I have shown you before, and I drop it, as the cone falls faster and faster, there comes a point fairly soon after it's dropped where it's going downward with constant velocity, and that's the result of the fact that the downward gravitational force and the upward air resistance force, this is actually a drag force, which we'll be looking at a little bit later, sum to zero. And that it would be an example of dynamic equilibrium.